Hi, in today's video, I'll be talking about different AWS Cloud Architectures. From the most basic, like just putting an HTML page in an S3 bucket, to what's a 2-tier architecture, 3-tier architecture, 4-tier architecture, and serverless architecture, their pros and cons, and if I'm the solutions architect for that environment, how would I improve that setup? Just a little bit of information about myself. I am Antonio. I've been in the IT industry for 15 years. And for the last 10 years, I've been focusing in cloud technology. I've had different roles the last 10 years. So I've started as a cloud engineer, then DevOps engineer, then SRE or site reliability engineer, and then there's platforms engineer, security and compliance officer, solutions architect, and I've also been in consulting. I also hold several active and expired certifications from AWS or Amazon Web Services, HashiCorp, and the Cloud Native Computing Foundation or CNCF. So that's my background, and let's get started. All right, the first setup in our list is the static website setup using an S3 bucket. This setup is particularly popular because number one, it's very easy to set up. Only a few components involved. Your DNS, which is root 53, and an S3 bucket with the same name as your domain name. So let's say you've got a website called example.com. You need to have an S3 bucket with the same name. And then inside that S3 bucket, you have your HTML files, like your main page. It can be called index.html. And for best practices, you got to add in an error page in there as well. And that's it. You've got a fully functioning website. Okay, let's go to the pros and cons for this setup. Pros for number one, very easy to set up. Not a lot of components involved. You only got your DNS, which is root 53, and an S3 bucket with the same name as your website name or domain name. Second items for the pros is that this setup is very, very cheap. It's the cheapest setup of all time if you just want to put a web page out in the internet. As for the cons, the functionality for the setup is very limited. In my years of experience, I've only seen this setup for advertising websites. For example, events like concerts or festivals. I remember I had a client a few years back, I think it's in Spain, and they were selling CBD oil. And this is their setup. It's just a web page about their products, their store address, their email and contact number, I think. And that's about it. Okay, now let's improve this setup. The first thing that I'm going to add is a CloudFront distribution. I'm going to put it here just to make the website faster. Now the CloudFront distribution, it makes your web page load faster because it caches the content in edge locations. So for example, I have an S3 bucket in Sydney and I have a client or a customer in the UK. The traffic travel time is quite far. So what the CloudFront distribution does is that it caches my content closer to where my potential clients are. So going back to that example of my client being in the UK, his traffic won't travel to Sydney anymore. It's just going to be probably in London, which is way faster. The next component I'm going to add in here is the AWS Certificate Manager. Having a certificate manager in my setup provides better security, and now my website can cater for TLS and SSL connections. Next is I'm going to add bucket permissions to my S3 bucket just to make it more secure. Okay, next is that, let me just expand this a little bit. And I'm going to create another S3 bucket in here with prefix of www.example.com. And then I am going to redirect the traffic to my main S3 bucket, which is example.com. And let me just add a line there. And lastly, I'm going to add in another S3 bucket. And this is just for the logs. So I'm just going to call it maybe website logs. And that S3 bucket will handle the logging for the website traffic. And that's it. On to the next. All right, so for the next architecture setup we're going to look at is the 2-tier architecture. Now, why is it called a 2-tier architecture? Because the networking is segregated. There's a public subnet and there's a private subnet. Think of it this way. The resources in the public subnet, let's say this load balancer here, the public internet can reach the load balancer And at the same time, the load balancer can reach the public internet. So it's a two-way traffic. While the resources in the private subnet, they're only one-way traffic. So what does that mean? One-way traffic towards the public internet. That means the public internet, for example, me, I can't reach the EC2 instances in the private subnet. Now maybe you're wondering, hey, Antonio, why does it need to reach out to the internet? What for, right? Because most servers, they need to be regularly patched, like security patches, OS patches. And for that, they need to reach out to the internet, grab those files or download those files and then install them. So they need the traffic out of the internet. And that is through the NAT gateway over here. This setup is quite common for those web servers that don't require RDS, or sometimes they put RDS in the private subnet, which is not best practice. We'll talk about it later in the 3-tier architecture. But for the 2-tier architecture, you shouldn't be putting RDS or DynamoDB or whatever database services in your private subnet. They need to be separated. They need to be in their own tier. So most use cases for this type of setup are web servers that don't require database or batch processing servers. Now, if I'm going to update this architecture with best practices, let me just add in Route 53 first. So I'm going to add it on top of here. Next would be the certificate manager or the ACM. It should be a staple for all AWS architectures. It's free SSL, which is very nice, and you're offloading that responsibility to AWS, which is a win-win. That ACM will be hooked up to the load balancer. And also I'm going to be creating a bastion host, or some people call jump host, in the public subnet. So that means if I need to troubleshoot an EC2 instance in the private subnet, I can first hop into the bastion server, and then from the bastion server, hop into that EC2 instance that has an issue. The next thing that I'm going to add in here is the EC2 autoscaling group. So if you're using EC2 instances for your compute resources, it's best practice to use the autoscaling group. That means you always maintain a minimum number of EC2 instances, just in case something goes wrong. For example, a data center or an availability zone going down, no problem. Your EC2 instance will be spun up in a different availability zone. So maintaining that number of minimum instances. And if your architecture is properly set up, then the autoscaling group will add or remove instances depending on the threshold that you set. For the next recommendation, is actually two-part. First is to use EBS volumes for your EC2 instances. Let me just put them there. And then the next would be to use KMS to encrypt the EBS volumes for the EC2 instances. And that's the 2-tier architecture. On to the next. Now let's look at the 3-tier architecture. As discussed previously in the last section, the resources in the public subnets, they're two-way traffic. That means public internet can reach to the resources in here, and the resources in the public subnet can also reach the public internet. Next is the private subnet, which is one-way traffic. That means the resources in the private subnet can reach the internet, maybe to download files like YUM updates or system updates or security updates. But the public traffic cannot reach the resources in the private subnet. The traffic has to go through the public subnets first. So that's why if I want to SSH to this EC2 instance over here, I have to go through to the bastion server first. And for this 3-tier architecture, we'll be introducing the database subnet, which is neither a two-way traffic or a one-way traffic, but a no traffic zone. So that means from outside the AWS network, I cannot reach this AWS RDS over here. And at the same time, this RDS instance over here, it cannot reach the public internet. So maybe you're asking, hey, so how does it do security patching or OS patching? AWS takes care of it, because these database services are AWS managed. That's the beauty of it. You don't have to do anything. Probably 60 to 70% of the architectures that I've done or managed before are 3-tier architectures. The only difference is like the compute resources here instead of EC2. Some companies, they use ECS. And some companies, they use EKS, but it's the same concept. And also for the database service, they're just different flavors. MySQL, Postgres, MS SQL, it doesn't matter. They belong in the database subnet over here. Let's go to the pros and cons. For the pros, I really like this setup because everything is segregated. The public-facing resources are in the public subnet. Your compute resources are in the private subnet, and the database resources are in the database subnets. And each of those tiers, they're segregated by NACLs and security groups. For the cons, not a lot really. Maybe more stuff to manage. Your security groups have to be on point. Your NACLs have to be on point. Other than that, it's a pretty solid setup. Now let's go for improvements. Now, if I'm the solutions architect for the setup, the first thing that I'm going to do is not use RDS, rather use Aurora. It just has more features than RDS, like auto-scaling, not just the storage, but also the instance if it's needed, and it's also AWS managed. And then I'm going to set up Aurora as multi-AZ or multi-availability zone. That way we have HA in place or high availability in place. Next would be I'm going to create another KMS key, and I'm going to use that new KMS key to encrypt the Aurora instances. Next is I'm going to update the security group for Aurora to only allow the resources that needs to communicate with the database. So in a case where the EC2 instances, they're the only resources that needs to connect to Aurora, then the security group of those EC2 instances are the only thing that's allowed to connect to Aurora. Lastly, it's not shown here, but the NACLs or the network access control list for the database subnet, it should only allow the IP range for the private subnet in the port that it's connecting to. Anything else should be blocked. And that's it for the 3-tier architecture. Next would be the 4-tier architecture. All right, so let's go to the 4-tier architecture and let's introduce this concept of management subnets. The management subnet is responsible for inter-VPC connection or inter-account connection, depending on your setup, but it connects different VPCs together by using the transit gateway. Let's say you have a dev account and a stage account, and you have a scenario wherein the EC2 instance from the stage account needs to connect to the database in the dev account. Weird, but it happens. So how do you do that using best practices? And that is through the transit gateway. So from the EC2 instance in the stage account, it will go through the management subnet in the stage account as well, where it has the transit gateway attachment, and all the way through the transit gateway, and it will find its way to the transit gateway attachment of the dev account, and then exit here, and then find its way to the database in the dev account. So as visual representation, the traffic will be like this. So that's the flow of traffic if the EC2 from the stage account is trying to connect to the database in the dev account. It'll go through transit gateway via the management subnet. For the pros and cons, of course, pros is you get to connect two VPCs together, which is a good thing if you have scenarios similar to this. As for the cons, not much really, aside from the transit gateway is a bit complex to set up. As for the improvements, you got security group and the NACLs similar to the tier 3 architecture, and I'm going to add in a VPC flow log for both accounts. That way, if there's any issues, it's easier to debug. And that's the 4-tier architecture. On to the next one. Finally, we've made it to the last architectural setup, which is the serverless architecture. And for serverless architecture, the scope is just too broad. You can use serverless for anything. It's just a matter of how good your development team is and how capable you are of retaining talent. Because once you get started with serverless, the tech debt is a lot. Okay, let's talk about the serverless setup. In the serverless setup, there are 4 widely used serverless services. First is the API gateway, which exposes the endpoint, whether it be HTTP, WebSocket, or REST APIs. Second is the Lambda functions, which we all know is a compute resource. Then we've got the DynamoDB, which is an AWS managed NoSQL database. Then you've got the S3 bucket, which stores your files, videos, pictures, whatever. So the usual flow for traffic for serverless is that someone or something or a service will hit an API gateway endpoint, and then that event will trigger a Lambda function to process something, maybe store data in DynamoDB or in S3, or maybe retrieve data from DynamoDB or S3. That usually is the flow of data for serverless infrastructure. Now let's talk about the pros and cons for serverless architecture. For pros, Serverless architecture is very cheap compared to 2-tier architecture, 3-tier, or 4-tier. So you only pay for what you use. And Lambda, API Gateway, DynamoDB, S3, these are very cheap services. There's even a famous knowledge streaming company worth tens of millions of dollars, and their AWS bill is like $80 per month. So it's insane because they're using serverless architecture. As for the cons, it's a very difficult setup, and most of all, the tech debt will be so high if your developer leaves. So please only do this if your team is capable and your organization is capable of retaining those devs. Let's go for improvements for serverless. First one would be I'd add a Lambda authorizer with the API gateway. This is particularly helpful if you want to know the caller's identity. And then next, depending on your use case, you might want to introduce Cognito if you have a need for identity and access management for customers. And then for Lambda functions, I'd suggest to use AWS Secret Manager if you need to retrieve any sensitive strings for passwords or usernames or whatever. And then for S3 bucket, you need to tighten up your bucket policies to enhance your security posture. Then lastly, for DynamoDB, if your use case needs it, you can use DAX, which is DynamoDB Accelerator. And that's pretty much it for serverless architecture and for this video. So that's the end of today's video, and I really hope you learned something new. Until next time.